Welcome to this explainer. Today, we're diving into a sector so unbelievably massive that if it were its own country, its GDP would literally rival entire nations. We are looking inside the U.S. aerospace and defense industry. And hey, this isn't just about building cool machines. This industry literally shapes how we connect globally, how we defend our borders, and, how we explore the universe itself. To really wrap our heads around the stakes here, let's look at a mind-blowing number: $1 trillion. According to the 2026 Aerospace Industries Association Facts and Figures report, this sector generated $1 trillion in total business activity in 2025 alone. To put that into perspective, that's enough capital to completely fund the construction of multiple megacities from scratch every single year. Within that massive number is $500 billion in direct economic value. So when we talk about an economic engine, we are talking about an absolute foundational pillar of modern global commerce. Here's our roadmap for today. 1. The trillion-dollar industry. 2. The ROI of R&D. 3. Boeing's century of flight. 4. Commercial, defense, and space. And finally, 5. Building a sustainable future. Section 1. The trillion-dollar industry. Let's unpack the raw economic power driving this sector. Now, you might intuitively think an industry this large would skew heavily toward one area, right? Like maybe leaning entirely into the booming commercial flight market, or perhaps dominated by massive government defense contracts. But it's actually a near-perfect split. Commercial aerospace accounts for 51% of direct manufacturing employment, while defense and national security hold the remaining 49%. This duality is absolutely crucial. It acts as an incredible economic shock absorber. When commercial travel dips, say during a global downturn, defense contracts step up to keep the factories humming, the supply chains moving, and the workforce employed. Digging a bit deeper into that workforce, this industry supports 2.1 million jobs nationwide. And because these are highly technical, specialized roles, the average industry wage tops $127,000. That's nearly double the median U.S. salary. And this employment isn't just scattered randomly. States like Washington and Kansas have deep, historic ties to World War II bomber manufacturing that have evolved into modern commercial hubs. Meanwhile, Florida and Texas leverage their massive spaceports and booming tech sectors. Together with California, these 5 states are the heavy lifters, collectively accounting for 44% of the entire nationwide aerospace and defense workforce. In an era where the U.S. imports heavily across so many sectors, aerospace and defense completely flips the script. In 2025, foreign demand for these highly advanced systems drove exports to $172.7 billion. That incredible global appetite generated a $109.2 billion trade surplus. That is the largest positive trade balance of any U.S. manufacturing sector by a really wide margin. The rest of the world relies profoundly on this domestic engineering. Section 2. The ROI of R&D. So, how exactly did we build an engine this dominant? Well, it definitely didn't happen by accident. Looking at historical data from Princeton University, we see that from 1945 to 1982, an astonishing $104 billion was poured into aviation R&D across military, civilian, and industry channels. This wasn't just throwing money at planes to make them fly a little faster. This massive, continuous effort gave birth to technologies we literally take for granted today. Early GPS networks, advanced weather radar, and the ultra-reliable commercial jet engines that allow safe transoceanic flight, they were all born from this specific era of heavy capital investment. It's a real testament to the long-term vision of aerospace engineering. The crucial takeaway here is understanding who actually benefits from all that research. Economists measure this by contrasting the private return with the social return. While the investing aerospace firm sees a very healthy private return of around 24 to 25%, the return to society is exponentially larger. But what does a social return actually mean for you and me? It means technological spillovers. That 70% maximum return to society, that's the overnight shipping logistics you rely on, the memory foam in your mattress originally designed for crash protection, the GPS right there in your phone, and the cheaper, safer flights for your family vacations. We all reap the rewards of these investments. Moving on to Section 3, Boeing's century of flight. Let's see how this multi-billion-dollar R&D plays out inside a real-world corporate giant. Boeing acts as a massive engine for the U.S. economy, but it's important to realize they aren't just one giant factory operating in total isolation. They're an interconnected ecosystem. With 140,000 U.S. employees, they manage a supply chain of over 10,000 different companies. We're talking mom-and-pop machine shops in the Midwest, advanced software startups in Silicon Valley, and specialized textile manufacturers on the East Coast. By pulling all these pieces together, they add $63 billion to the U.S. GDP every single year, holding 15% of the global commercial aviation market share. And their current dominance? It was built upon a century of solving seemingly impossible engineering problems. They started humbly back in 1916 making wooden seaplanes. By the 1940s, they were building the vital B-17 Flying Fortress. They pioneered the jet age with the 707 in 1958. But honestly, perhaps their most defining moment was the 747 in 1969. The 747 was this massive financial gamble that almost bankrupted the company, but it literally changed the global economy by democratizing international travel, suddenly making it affordable for the middle class to cross oceans. Decades later, they expanded their defense footprint with the McDonnell-Douglas merger in 1997. Section 4, Commercial, Defense, and Space. Today, that century of legacy engineering translates into multiple distinct divisions. In their commercial division, they target highly specialized solutions to global transportation problems. On one hand, you have the 737 MAX, engineered specifically for fuel efficiency on shorter, regional hops. On the other extreme, the 787 Dreamliner and the 777X are built to connect massive long-distance routes. And they achieve this through advanced materials. The Dreamliner, for example, makes heavy use of carbon fiber composites rather than traditional aluminum. This doesn't just make the plane lighter, it actually allows the cabin to be pressurized at a lower altitude and hold higher humidity. For you sitting in that seat, it means arriving at your destination significantly less jet-lagged and dehydrated. Pretty amazing, right? But passenger jets are only part of the equation here. Their defense and space security arm tackles extreme environments, producing military mainstays like the Apache helicopter and the FA-18 Super Hornet, as well as pushing into the final frontier with the Starliner spacecraft. These extreme environments, whether a combat zone or the vacuum of space, force rigorous engineering breakthroughs. The materials, the software, the autonomous life support systems developed here inevitably trickle down, continually raising the baseline for safety and efficiency in the commercial flights we take every single day. Section 5. Building a sustainable future. Because dominating the last century absolutely doesn't guarantee the next. The industry now faces its ultimate engineering test, surviving the environmental challenges of tomorrow. Boeing has formally committed to becoming completely carbon neutral by 2050. To hit a target that ambitious, they're pivoting toward technologies that honestly sound like they belong in a sci-fi novel. They're actively pioneering electric vertical takeoff vehicles. Just imagine taking an electric air taxi across a heavily congested city with the exact same ease as ordering a rideshare today. They're also utilizing AI-driven autonomous systems for hyper-efficient navigation, aggressively testing all these cutting-edge methods to slash emissions. But the biggest hurdle over the next decade is bridging the gap between our current planes and a fully electric future. Boeing aims to have all new planes capable of running on 100% sustainable aviation fuel, or SAF, by 2030. Now, the real magic of SAF is that it isn't pumped from the ground. It's manufactured from everyday waste, like used cooking oil, agricultural leftovers, and solid municipal waste. It can be dropped directly into the jet engines we already have, meaning we don't need to rebuild the entire global fleet from scratch. Scaling this up can cut carbon emissions by a staggering 80%, fundamentally cleaning up air travel in the near term. Knowing that this $1 trillion industry was built on a foundation of relentless research and development, we absolutely have to look forward. We went from wooden seaplanes to reusable spacecraft in just 1 century. So as we stand on the edge of zero-emission autonomous flights, electric air taxis, and deep space exploration, the question isn't whether aerospace will reshape our world again, but whether our imaginations are big enough to keep up. Thank you so much for joining me on this explainer.